Hello class, welcome to week 14 of Programming Logic with Python. So this video is going to be the homework walkthrough, or lab walkthrough video. Originally, as you saw on Blackboard, I had two separate entries for two videos, one for the lab walkthrough, one for the kind of topic overview. But because this week is there's not really too much of like a new topic it is a new topic, but it's kind of like these past couple of weeks have been very conceptual, as in like, you read about it and you kind of just have to know what it does. There's a little bit of new code that we learned this week, but it's not too much that I kind of thought that there should be a dedicated video for that. So I figured I'd kind of incorporate my thoughts on this new topic for this week in this video. So this video is going to kind of be like a combination of the topic overview and the homework walkthrough. So before I get started with the first lab, I do want to mention that there's three labs for this week. There's 9.2, 9.3, and 9.4, I believe. But what I'm thinking is 9.4 I'm probably going to remove from the mandatory homework assignments for this week, only because it kind of covers, let me see if I can get to it. Yeah, it kind of covers a topic that is a little bit more complex, and the book doesn't really cover the topic a lot. They give it like one page and like one paragraph at the very end of the chapter. And in the PowerPoint, I also briefly covered it as well. It's not going to be on test 3, so I kind of figured since it's not on test 3, the book doesn't really cover it, yet they have a homework assignment for it. It's not really fair to you guys. So I think I'm going to remove 9.4, so just check Blackboard under under week 14 under assignments or homework assignments. There'll only be two lab activities, 9.2 and 9.3. So now that that's out of the way, I'm going to include that in this week's class announcement that I'm removing that third homework assignment for this week. So it's just going to be the first two. I think the first two are really the most important things. Identifying error scenarios and handling errors. When we get to custom exemptions, that's more of an advanced topic like I mentioned, so don't feel like you're missing out. It's an advanced topic. And it's not that you guys can't do it. It's that if the book doesn't really explain the topic, I don't feel like I should further expand on it when the book is saying, okay, well, for an intro course, let's stop here. I don't think it'd be fair to kind of introduce a topic that even the book says isn't fit for an intro course. So that's kind of why I'm keeping it out. I hope it's okay with you guys. So let's get into the first lab activity. So 9.2, which is identifying error scenarios. So as this opens up, so for this week, since this is a combination of topic overview and lab walkthrough, I do want to mention that the PowerPoint for this week is actually super, I think, helpful. If you don't want to kind of comb through this chapter's textbook reading, because sometimes the textbook reading, while it is short, um, it could be not your style. I know I wasn't a huge fan of reading textbooks, but I ended up reading them anyways. But if you prefer not to read the textbook for this week, I feel like the PowerPoint's actually really good. Um, so I would say go through the PowerPoint. Ideally, go through both, but the PowerPoint I highly recommend for this week. So yeah, and like certain slides from the PowerPoint, will also help you figure out the concept behind these labs if you're kind of confused as to why we do stuff a certain way. But this first lab is identifying error scenarios. So there's two types of errors that they want us to create or generate. So the first is a key error, and I explain what a key error is in the PowerPoint, and then the second is an attribute error. So I'm not going to explain these errors specifically because I already include them in the PowerPoint, but let's go to making these errors occur in our code. So this first thing at the very top just explains the scenario. This line's actually pretty important, and it's probably going to be one of the lines that might trip some of you guys up. So it says in order to generate both errors, we need to generate them one at a time. Meaning, when I write the code for this first error that's going to be up here, um, that code I do have to comment out, or at least a certain line, so that when the code runs for the second error, it doesn't trip up on the first error and just stop the code entirely. I need to remove whatever line I'm going to write here and then just allow it to run the second task so that this second task can generate an error. But we'll get to that. I'll show you how to do that. So the very first task, which is going to be the key error that we're going to generate, the first thing they want us to do is to create a function called createError. So they already do that for us, so we can kind of skip to this next line. So within createError, they want us to create a dictionary. And they give us the exact code, so like this entire piece of code, I can actually just copy and paste it if I wanted to. And obviously I have to fix the indentation levels. Or you could write it, it's really up to you. So that's my dictionary. Hopefully it doesn't... yeah, hopefully... I'm just thinking hopefully it doesn't give me an error. I don't believe it should give me an error for indentation level inside of a dictionary. So that should hopefully be fine. So let's move on to the print statement. Okay, so now in the print statement, they want to see use a key that's not defined in this dictionary. So I guess the easiest way of doing this would be just to say like, well, we could just write the key. So like, if I were to go actually, no. Let's write a whole sentence. Even though it's not quote unquote the easiest thing to do, I think writing the whole sentence is probably like it'll make the most sense. And if I just were to declare a certain key in here, so let's write I went to eat at, and then here, so you might notice the F in front of my string right here. That just means that we went over I think like 2 weeks ago, 2 or 3 weeks ago. It's just like a little it's I guess a something you can use in Python that allows you to create a string, and then inside of your string you can just include variables without having to like separate them. um, it just allows you to create, I guess, like mesh different data types, so like a string and a regular variable that might hold a integer value, might hold a in this case a dictionary value. So um, it just gives you that flexibility, so that's why I'm using it here, just to make my life easier. So inside of these curly brackets, I'm actually going to put my dictionary. I'm going to call my dictionary, which is dining. Dining. Okay, I spelled that right. So dining, and then I'm going to do my square brackets, and now here I'm going to put whatever key I want to call. So the key I want to call is name. So after I do that, so inside of the dictionary of dining, I'm calling the key of name. And obviously the name, the value associated with name is Johnny's Restaurant. So I went to eat at Johnny's Restaurant is essentially what I'm writing. I'm going to continue my little sentence. Yesterday in. And so now instead of doing like including the key of location, I'm actually going to include a key that doesn't exist, because by doing that, I'm actually going to create, or I'm going to generate that key error. So let's do, I still have to call the same dictionary of dining because that needs to be called. I can't just call like a dictionary that doesn't exist because that's not a key error at that point, that's a different error. So I'm still going to call the dictionary of dining, but now I'm going to call a key that obviously doesn't exist, so it's not name, it's not location. So we can call something like, um, we can call like address, right? And then right at the end of that, I'm going to do period, quotation mark. And so now if I run my code, I do python 3 main.py, So now oh, indentation level. Okay. I kind of figured it'd be an indentation level. So let's see if I can fix this. I'm just going to actually. Okay. It wasn't the dictionary, it was actually my print. Okay. My print had to be at the same, it couldn't be at the same level of my function up here. It had to be at the same level as the dictionary that I created, so that's on me for not noticing that. You could have your dictionary like this, I believe. It shouldn't matter. So if I run this again, yeah, it shouldn't matter. So if I go here and do the check mark, yeah, it gives me 1 out of 1 checks. For the second one, it's obviously not gonna, yeah, it shouldn't give me a check. I had an answer there before, that's why there's a check there. But let's go to the second one. So before we move on to the second task, remember I said that you had to comment out a line of code so that this first error doesn't mess up the second error. So it's technically just going to be this line, because this is the line that we're actually using or calling a key from our dictionary that doesn't exist. But for now, let's keep it, and I'll show you why that's necessary. Um, so let's move on to the second task. So the second task is saying write a print statement that uses a key. Actually, no, is it? No, that's not it. Um, not to find a dictionary. It's this. Okay. Um, it's weird how they did this. Okay. So to generate an attribute error, import the string module. Okay, so the first thing we're gonna do is we're gonna import string module. So import string. That's literally it. Because we learned about modules last week. So when we want to import a module, as you know from last week, we just literally write import module. It's like importing either another program that we've created or like a built-in module from Python. But that was something we covered last week, so you guys are probably still familiar with it. So the second thing we're going to do is we're going to use an attribute that's not defined in the string module. So this is very simple. They just want us to use a an attribute, meaning like a kind of like a not a variable, but like a it can kind of be like hmm, think I think it might be better to say like think of an attribute more. It could be like a variable or it could be like a function. So like a function or method that belongs to the string module, and module being just like a C++ program. Whether it's user this in this case it's like a Python built-in module. So let's use some like a an attribute from the string module. So if you're not familiar with certain attributes that are used in the string that are included in the string model, they actually give you an example of one down here. So like they have their output below which says attribute error module string has no attribute, and then this is what they've tested out. So this is ASCII letters. That's not a valid attribute from the string module. So we can just use this. It saves us the headache of having to Google attributes for the string module. So let's use that. So the way we're gonna do this is I'm just gonna create a variable called a. I'm gonna assign it a value of it's gonna be string because I'm using the string module, period. And now I'm gonna write this ASCII letters. And that's pretty much it. So we have return right here, and then use this code to test your function. So I'm gonna actually run this code, but it's gonna give me it should give me the key error. Yep. So right here, notice that it says key error, and that key error is because it's running from top to bottom. So it's running this code. This is creating this function, It has this dictionary, and then it's running this print line, and at this print line, whoops, okay, I messed that up. um, how do I backtrack? Well, you get the point. So, okay, I fixed it. So it's running this print line, and at this print line, it generates the key error, and once it gets to the key error, it stops the execution of the code. So this second task, task 2 right here, never runs. And so even though we wrote this correctly, it'll never give us a full check because this piece of code never runs because it stops at the key error, which is why it's important to comment out this line. So now if we run it, if we do Python 3 main.py on the right hand side, so now actually did I misspell this? Um oh no, this is right. Okay. So now when I run it, I do get an attribute error, and that's what we want. So now if I click on this, yep, I get my attribute error, and that's it. So we just essentially use pieces of code, this being from last week, this being from a couple weeks ago when we were doing dictionaries, just using code that we know from previous weeks to generate errors. That's all this activity was for. So pretty simple, pretty straightforward. Obviously, if you want to know what an attribute error and what a key error is, just go to the PowerPoint. It's like a sentence of explanation. Um, Fairly straightforward. Uh, and that's it for that lab. So for the second lab for handling errors, this will be the last lab that I go over in this video. So it's going to be a pretty short video. The PowerPoint's, I think, 18 slides, so the PowerPoint might be like, it's probably longer than this video, as far as like the time you'll probably have to spend on it. Um, so this will be the last lab because, like I said, we're not going over that third lab. We're not. That's not mandatory for this week. I'm going to remove that. So this one is handling error. So we've generated error, so now we have to handle it. So like, what happens when we get an error? Just like it just happens. How do we deal with that situation? Um, so here they're saying, let's see, in this activity we will practice handling errors. The snippet of code in 9.53 throws an error, so this piece of code is going to throw an error. Identify and handle the error so that when it occurs, the message is printed to terminal. Um, okay, so the way we can kind of go about doing this is they actually tell you. I was just gonna say. So they want us to use the try and except kind of block of code to handle this particular situation. And that is also included in the PowerPoint. So if you guys want a explanation on the try except or keywords, it's definitely there. It's like a sentence as well. It's not too complicated of a concept, which is why I'm not including it in this video because I don't want this video to be super long. Because while it is a sort of topic overview, it's at the same time the lab walkthrough. And the lab walkthroughs I tried not to make too long. So the try except kind of syntax is you write try colon, and then when you press enter, it's going to indent for you. We're going to keep this print statement as is because we do want Python to attempt to run this code. And that's kind of what try does. It attempts to run a piece of code, even if it throws an error. And then when it does throw the error, that's where we're going to put the except. And in this case, they want us to have our except block make the exception look for an attribute error. So if we wanted to look for a specific error, in this case the attribute error, and did they spell this wrong? I don't think there's a U here. Um, Error, okay. And then you end it with a colon. It's going to indent for you. And so for this attribute error, I do want the user to kind of know what's happening when this error occurs. So I'm going to print out a print statement or like a string to the user letting them know to double check the attributes in their code and try again. And that's pretty much it. I believe that's all they're really asking for. So yeah, it was gonna error out anyways. So if I didn't have this try, we can kind of see what happens here. So okay, well, um, just in case, I want to make sure that's the correct error message it gives me. Okay. Okay. So yeah, it gives me an attribute error and it just says module random has no attribute rand integer, which is fine. So like it will generate an error as they mentioned up here. Um, so when we included try, you can kind of see what it does. Main.py. Okay, so you can't really just leave try by itself because it expects either accept or finally, and both of those are included in the PowerPoint. So when we do accept, say we didn't do attribute error. I just kind of want to show you what different things will output, just so that you're kind of like understanding the point of doing try, the point of doing accept. Um, so maybe I should uncomment out that line. Okay, so double check the attributes in your code and try again. Okay, so correct error type was display declared in the accept statement. Okay, so yeah, even though this code itself with the try and accept and then the print statement that we wrote um, gives you the same output as it did originally up here, I believe it was right this line. It's not going to give you full marks unless you do a space and then type attribute error right there. At which point, if I check it now, it should give me 10 out of 10. Yeah. Um, so when you do include the attribute error, it specifically looks to see if this error message in this first line of code outputs an attribute error specifically, because if it does, then we're going to print out this. You could say, oh, well, it printed that out regardless. It only printed that out because we got the error originally, and then when we got the error, we said, okay, well, this is going to error out, so accept, or really just means if it gives you an error in the original try section of the code, then just print out whatever's underneath accept. Um, but it's kind of two ways of getting to the same endpoint, but when we get into a more complicated and more advanced way of handling errors, specifying an error and a message that goes along with that error does kind of make more sense. But in this very elementary level introduction to the topic, you can kind of see you can go without it. But just make the habit of including the specific error you're looking for right after the accept keyword. Um, Not only for Cengage, but just it's good practice. But sometimes you don't know where error, or you might guess like certain errors might occur, and like maybe we have another accept after it, and maybe this is going to handle a different kind of error. Maybe it's going to, what was the other error that we um, I think it was like key error. Maybe, yeah, maybe it handles a key error, and then we print out um, key not included in dictionary. Dictionary. Okay, yeah. And then I do like my Python 3 main.py. So okay, right here. I guess this was a pretty good example. Even though there's two accept outcomes. There's the attribute error accept, and then there's the accept for key error. Notice that it only printed out the attribute errors print statement and not the accept print statement. Why? Because this error under the try outputted a attribute error right here. And because of that, when we did the accept and we specified the specific error we're looking for, once it identified the attribute error here on the right hand side with the attribute error syntax after the accept, it said, okay, I'm just going to print whatever's underneath here. I'm going to ignore everything else if it's not related to attribute error. So key error, because that's a different type of error, this print statement never gets printed out, and we see that right here. So I guess it was good to include that. It's valid code, and like I said, as you get more advanced, you end up putting more, um, I guess, outputs for different types of errors that might occur in your code. Um, but those won't get printed out. Only the specific error that actually does occur. But that's pretty much it. I kind of overcomplicated it by including this line of code. This line of code's not necessary. It was just here for demonstration purposes. But that's it really. I mean, that's handling errors. Use try and accept and use finally, which we didn't use here, but it is included in the PowerPoint. This last example is creating your own exemption. Um, I'm just gonna open it and just kind of like talk about it, I guess, just a little bit, not too long. So if it's not obviously not mandatory, pretty much, I kind of actually wrote the code up here, which is good. So they created their own quote unquote exception class, and they called it invalid. Well, I called it invalid recipe. And if you're going to create your own exception class, you have to include error at the very end of your class. And here they said to include the exception class as your argument as well. So that's why I wrote it in here. And obviously this is a class, so I wrote class at the front. Below it, they told me to create a function called init, which we learned in past weeks, and the self inside of my init function, obviously from past weeks, we know that this is mandatory. It's the first parameter. It always has to be the first parameter, but you never really pass an argument for self, so you never have to worry about that. When we're creating, I guess, attributes or variables for my init class, we do have to include self period and then whatever um, variable we're creating. In this case, I created a variable called error, and I equated it the string of invalid recipe try again. So what happened in this second block of code right here, the try except, as we saw in the previous example, I use the keyword of raise, which is going to raise, well, hold on, let me, I think it'll be best if I get the PowerPoint up because I keep on referencing the PowerPoint, but, it might be best if I just pull it up. So let's see, let's go to content, let's go to week 14, error handling. All right. Okay, how to raise an exemption. So use the keyword raise. We want to raise exceptions when something occurs and when you want to inform the user that the input given is incorrect. So that's why we would use it. So if we go back here, we want to raise this uh, this specific exception class that we created. So that's why I'm saying raise and then this. I'm raising this whole class that I created of invalid recipe error, and I'm saying when this is created, this is obviously this is an error. It's going to say invalid recipe. Try again. So that's going to error out for my try keyword, and then when I say my accept, uh, I'm saying accept, and I'm specifying the specific type of error of invalid recipe error, and I'm saying as are. So that's really just saying when you see this error, just assign it or change it to a variable called r, like assign that error to the variable r, and then when I go to print inside of my except body of code, I'm saying print r period error. Because remember, error right here is the actual string of invalid recipe try again. So when I do Python 3 main.py, it gives me invalid recipe try again. So I guess the only thing that might trip you up is this as, using the as, assigning this custom exception class error to a variable of r, and then well, to, I say variable, but it really should be like an object, a class variable object, something like that. Um, and then r is really taking the place of self, so it's really saying like r period error is invalid recipe. It's they make it more complicated than it needs to be, but it is kind of used for these scenarios because it is a more advanced topic. Um, and it's really when we have an error that we want to use in our code that the custom built-in errors don't fit. So like in this case, like say a user is looking for a recipe in our list of recipes, like not for the specific code, I'm just saying for another example, like we have a dictionary of recipes and the user's trying to search for a recipe um, and they can't find it. Um, Obviously, we could use the key error um, for that specific example, and that would be valid. But if we want a more specific thing, we could create our own error exemption class, uh, and that's what this is. But this is not going to be on the test. I kind of just went over it just because if you're, I guess, curious about what this is and want to do the lab yourself, but you just don't know where to start, I figured I can kind of go over it, even though it's not mandatory. You don't have to do it. I'm going to remove it from the mandatory list of homework assignments. But if you want to try it yourself, here's the code it runs. And if I go here, it should give me the full checks. If I just exit this out. Yep. So it's there. And that's really the last lab activity for the semester. That's crazy. But yeah, that's it. The PowerPoints here, I include all the specific built-in exemptions. It's all here, syntax, import, key. So we kind of went over import, key, attribute, those three pretty much. And you guys have seen syntax errors throughout the entire course, I'm sure. It's very common. And I kind of just like have a slide for each of them. Some of them have pieces of code, some of them have little screenshots just to show you. And then I have one for try and accept. And then I have uh, another slide for the multiple accept, which is what I kind of did. And then you have the else, which we didn't specifically go over in the lab, but it might be on the test. I don't know. Um, and then we have finally. So else and finally, definitely look through those. Custom exemptions, I even put like this last bullet point saying, don't worry, it's not going to be on the test. And the other thing I said that wasn't going to be on the test from this chapter was this. So file not found error. I also say don't worry about this specific exemption. But the rest of them do become familiar with them. Just read through them. It's not long. I believe it's only 18 slides, but definitely take the time to read through that. Then you have your chapter reading and this video. So that's pretty much it. That's kind of all I had to really say about this video. Like I said, there's not going to be a topic overview because this topic isn't super complex. It's very, you just have to read it. It's like one sentence. This is a specific error. This is what it does. And how to handle it is obviously with the try, what was it? Um, try accept, try accept accept, try accept else, and then try uh, either el or try accept or try finally. There's a bunch of different combinations you could have. Um, but it's just reading it and just knowing the definition, and then the try accept is relatively straightforward on how to use. That's it, really. That's why I didn't want to include a whole nother video on it. I figured I could just do a sort of combined video for this. That way you guys don't have to watch two videos, just watch one. And that's pretty much it. So it was, since this is the last video I'll be uploading for this semester, because next week is test 3, which is the final test of the semester. Um, I just want to say that I enjoyed this semester a lot. Even though it was an online class and I didn't really get to see you guys, it was me just kind of talking at the computer. Um, I enjoyed being able to share my knowledge of Python with you guys throughout each week, throughout the semester as a whole. I hope that you guys are able to walk away from this course just knowing a little bit more and just not feeling intimidated by coding in general. Because as you guys have seen, coding is really just like you can break it down into little steps as I broke it down into week by week. And it's just like, it's not difficult concepts to learn. If you break it down week by week, as I have, even as you guys move forward into maybe learning other coding languages or just refining your skills in Python, just take it step by step. When you learn a new coding language, when you advance in a specific coding language that you're already familiar with, just always take it step by step. Don't ever feel intimidated. Um, Coding it looks scary from the outside, but once you get in it, as you guys have, you realize it's not that big a deal. It's really just like applying common sense concepts that you've learned throughout your education into code, whether it's through loops, whether it's through functions or classes, or if conditional statements, if else statements, like if something happens, then this happens. If not, then the other thing happens. All stuff that's are concepts that we've learned in other areas of our lives that we're just applying to our code. Um, so hopefully you guys have walked away from this course more comfortable in Python or just in coding in general. Because that was the goal. Obviously, it's a little bit difficult when it's not face to face, where I could answer your questions directly. As I'm introducing a topic, you guys might be able to ask me questions directly. So that kind of is a bit unfortunate that it was a fully online class, but I do hope these videos did help you guys throughout the semester. And um, and yeah, that's it. I really enjoyed having you guys as my students. Um, and I study for test 3. I guess that's really all I can say. Study for test 3, um, and do well, and then keep on going through the rest of your courses at Tunxus and get that degree. Keep on fighting through each course. I know it's tough. I was a student too, um, but it's worth it at the end. So just keep moving forward, not just through this course, through all your other courses. If you have more semesters coming up, just keep kind of fighting through them, and you guys will be okay. Um, all right. So once again, it was a pleasure being your teacher, your professor for this semester. Um, I If I have you in future semesters, great. If not, it was a pleasure. Um, so yeah. All right. Bye, guys.